All right, today's lesson is how to solve for theta using SOHCAHTOA. So first thing we're going to do is write SOHCAHTOA because this is a right angle, so SOHCAHTOA. And if you need help solving for a side, you can always watch the last video about how to solve for a side using Trig. To do this problem, we're going to label exactly how we did before. Across the 90 is H. Across theta is O, and that leaves me with A. We want to think in terms of doubles only, so I've got H with 20, O with 15, and A is single. So anything with an A, we want to get rid of, which narrows down your trig function to sine. I'm going to go ahead and take the time to write out the ratio. Sine of theta equals O over H. And before I do anything with my calculator, I want to make sure it's in the right mode. So to do that, I press the mode button. I can see the degree is highlighted, so I can just press clear and move on. Just take the time to press mode and check your calculator. So now we're going to substitute. Sine of theta equals 15 over 20. Now in this type of problem, my unknown variable is the actual angle, and we're going to be utilizing these pieces of your calculator that have sine to the -1, cosine -1, and tangent -1. These allow you to solve for the angle measure. So since this is sine, to break apart sine and theta, I need to use my -1. So I'm going to multiply the left by sine to the -1. And multiply the right by sine to the -1. What that does is it allows sine to the -1 and sine to cancel, freeing theta. And then I'm going to write my sine to the -1, parenthesis, 15 over 20. My theta is isolated, so that lets me know my calculator can be used. So I'm going to press second sine, and notice how it pulls up the -1. And then I'm just going to type this fraction in, 15 over 20, close parenthesis, and press enter. And that rounds. We usually round to the nearest whole number, so this 5 bumps up this to a 9. So my angle measure is 49 degrees. Okay, let's try another one. So again, I see a right triangle, so my brain should write down SOHCAHTOA. And then I'm going to go ahead and label. Across the 90 is H. Across my theta is O. And that leaves me with A. Doubles only, so the only side that has a single is H. So sine and cosine are out. And tangent is left. I'm going to take the time to write down the trig function. So tangent of theta equals O over A. And then I substitute. Tangent of theta, I don't have an angle, equals opposite 13 over adjacent 15. My variable in this case is still theta, so to get theta alone, I have to use an inverse trig function. Since this problem is tangent, I'm going to go ahead and use tangent to the -1. You've got to match your trig functions. If it's a sine problem, you use sine to the -1. Tangent, you use tangent to the -1. So your tangents end up canceling, and you're left with theta equals tangent to the -1 of 13 over 15. I'm going to go ahead and type that into my calculator. Second tangent brings up the -1. 13 divided by 15 gives me an answer rounded to the nearest whole number of 41 degrees. Let's try the last one. So on the last one, we're going to use SOHCAHTOA again. That's a right angle. So I'm going to go ahead and take the time to just write SOHCAHTOA. And then I'm going to go ahead and label my picture. Across the 90 is H. Across theta is O, leaving you with A. Doubles only, so the single one is O. So if anything has an O in it, that means we can't use it. So cosine is the function for us. I'm going to take the time to write down my ratio. Cosine of theta equals A over H. Now we're going to substitute. Cosine of theta is still unknown, equals a 30 over hypotenuse 45. My variable is theta, so to isolate theta from cosine, I must use the -1. To do that, I'm going to make sure that I go ahead and multiply both sides by cosine -1. Cosine -1. These cancel, and I'm left with theta equals cosine to the -1 of 30 over 45. Theta is by itself, so second cosine, 30 over 45. Rounding to the nearest whole number will give me an answer of 48 degrees. Things to remember when you're solving for these problems: the hypotenuse must always be the larger number. So just make sure, just make sure that you're substituting correctly, and just know if you're solving for your angle, you have to use the -1 trig functions.